All right, let's dive right into this explainer and discover how to transform seemingly impossible letter math into solvable puzzles using pure deduction. Because let's be honest, if you've ever looked at words stacked up like a math problem and thought, how on earth am I supposed to add letters together, you are definitely not alone. We're going to crack that code together today as we decode the absolutely fascinating world of alphametics.
Take a look at this equation. A plus AB equals BCC. Now ask yourself, if these letters represent digits, how do we actually solve this without just, mindless guessing? Whenever I stare at something like A plus AB equals BCC, it looks like a secret code, right? Most people's very first instinct is to just start plugging in random numbers. They'll say, well, maybe A is 2 and B is 4, and they quickly get completely tangled up in a web of wrong answers. But there is a much better, far more satisfying way.
Here's our roadmap for today. We're starting with our Welcome to Digit Decoders. Then we'll build out the core decoding toolkit, run through the Level 1 carryover sprint, tackle Level 2 parity puzzles, and finally wrap up by mastering full cryptorhythms.
Let's move right into Section 2, the core decoding toolkit. This is all about tools over guesswork.
So the absolutely crucial thing to grasp here is that an alphametic isn't magic, it's a strict mathematical system. Also known as a cryptorhythm, the rules are delightfully simple yet completely rigid. Every unique letter represents a unique digit from 0 to 9, period. If A is 5, then every A in the entire puzzle is a 5, and no other letter can be a 5. It is a closed system, and because it obeys the basic laws of standard arithmetic, we can logically crack it open.
Our core toolkit emphasizes the vital role of column addition. We really have to think in terms of units, tens, and hundreds columns, exactly like we did in elementary school math. When a column adds up to 10 or more, it generates a carryover to the next column on the left. Recognizing those carryovers, understanding odd and even numbers, which we call parity, and organizing what we know into tables are going to be our primary weapons.
As you can see laid out here, organizing our constraints systematically helps us eliminate digits instead of guessing blindly. Notice that A cannot be 0. Why? Because in mathematics, we don't write numbers with leading zeros. A number like 05 is just written as 5. This one tiny constraint, the fact that leading letters cannot be 0, is actually incredibly powerful.
All right, let's level up. Level 1, carryover sprint, focusing on leftmost logic.
You've got to keep your eyes on this rule because it is the absolute secret weapon for breaking open Level 1 challenges. Think about it. What is the absolute maximum value we can get if we add two two-digit numbers together? Well, 99 plus 99. And what does that equal? 198. It doesn't even reach 200. Therefore, if we're adding two two-digit numbers and getting a three-digit answer, that resulting hundreds digit absolutely inevitably has to be a 1.
What's really fascinating here is how we can expand B plus BA algebraically to track exactly where that carry comes from. Look at the equation. B plus BA equals ACC. BA isn't B times A, right? It's a two-digit number. It's 10 times B plus A. So algebraically, we're really looking at B plus 10B plus A. That gives us 11B plus A on the left side. On the right, ACC translates to 100A plus 11C. We are literally tearing these numbers apart by their place value to see how they tick.
By stepping through the logic one deduction at a time, we conclusively prove that B equals 9, A equals 1, and C equals 0. Let's actually walk through it. Since the result ACC is a three-digit number coming from a single-digit B and a two-digit BA, as we just uncovered, that leading A absolutely must be 1. If A is 1, then our result is 1CC. So B plus B1 equals 1CC. For a single digit and a two-digit number starting with B to breach the 100s, B has to be huge. It has to be 9. 9 plus 91 equals 100. So C is 0. No guessing at all, just pure logical deduction.
And applying that exact same rule to a new puzzle, the carry here forces E to be 9, F to be 1, and G to be 0. We have a single-digit E plus a two-digit number EF, giving a three-digit answer FGG. The newly created leading digit F must be 1. If F is 1, then the equation is E plus E1 equals 1GG. To get over 100, E has to be 9, so 9 plus 91 is 100, leaving G as 0. It's the exact same beautiful logic pattern, just wearing a different alphabetical disguise. Moving right along to Level 2, parity puzzles and the incredible power of odds and evens. Compare these immutable rules carefully, because knowing whether a resulting digit must be odd or even limits your possibilities drastically. It basically chops your entire list of potential digits right in half.
If we know a letter has to represent an even number, we don't even have to waste our time testing 1, 3, 5, 7, or 9.
Let's actually test that parity logic on this doubling pattern. In HE plus HE equals SHE, what are our only numerical options for E? Look strictly at the units column on the far right. E plus E yields a number that ends in E. Think about your digits for a second. 1 plus 1 is 2. 2 plus 2 is 4. 3 plus 3 is 6. None of those match. So what actually works here?
Let's completely unpack the logic. Only 0 plus 0 equals 0, and 5 plus 5 equals 10, ending in the exact same digit they started with. So E is either 0 or 5. If E is 5, we generate a carry of 1 into the tens column. Then we'd have H plus 1 equals H. But mathematically, if you add a number to itself and then add 1, you cannot get the original number back. It totally breaks the system. So E cannot be 5. It has to be 0. And if E is 0, then H plus H equals a two-digit number starting with S. S must be 1. And what single digit added to itself gives a number starting with 1 and ending in 0? 5 plus 5 equals 10. So H is 5, S is 1. Boom. Solved.
All right, final stage. Section 5, Mastering Full Cryptotherms. Putting it all together.
Solving iconic level 3 puzzles like send plus more equals money or base plus ball equals games requires weaving together absolutely everything we've just learned. These aren't solved in one magical, intuitive leap. They're unraveled slowly, combining that leftmost carry logic, units column parity, and constraint tables all at the same time.
So the absolutely crucial point here is discipline. You must move from right to left and never, ever drop a carry. Think of a carry like a baton in a relay race. If the units column passes a 1 to the tens column and the tens column forgets to add it, the whole team gets disqualified. The entire puzzle collapses. We have to track them meticulously.
Before you go running off to solve these, we need to guard against some very common pitfalls, especially the overwhelming urge to guess without a logical foundation. It's so tempting to just plug in our favorite numbers, but as these mistakes show, that's a trap. Remembering that each letter is a unique digit, never putting a 0 at the front of a word, and hunting for those hidden carryovers will save us literally hours of frustration.
I absolutely love this piece of advice because it ensures your entire puzzle won't collapse due to a single overlooked error. Whenever you lock in a letter, rewrite the math problem with the numbers. Do the actual column addition. See if it holds up before moving on to the next letter. It is your ultimate sanity check.
So, armed with your brand new decoder toolkit, are you ready to take out a pencil and conquer this final puzzle? Take a look at cross plus roads equals danger. Where do you even start? Well, look for the newly created leading digit. Think about those double S's in the units column. Apply the parity rules. You actually have the skills now to decode this. Grab some paper, set up your constraint table, and see if you can crack the code. Honestly, if simple arithmetic can hide such beautiful, rigid logic, it really makes you wonder what other everyday systems are just waiting to be decoded. Thanks for diving into this explainer with me, and happy decoding.